What if everything you think you know about learning is not how intelligence actually works? What if learning doesn't require understanding, memory, or even awareness? Because there is a machine today that has read more text than any human in history. It has seen patterns in language, images, behavior, and logic at a scale no brain could ever hold. And yet, no one ever taught it what those things mean. So here's the real question: if something can learn without being taught, without explanations, without guidance in the way humans knight it, then what exactly is learning? And more disturbing, if AI is learning in a completely different way than us, are we still qualified to call it intelligence in the human sense? Or are we witnessing the emergence of something that obeys a different definition entirely? In the last episode, we asked when AI started thinking. But thinking is not where this story begins. Before thinking, there is learning. And what AI is doing there is far stranger than most people realize. For most of human history, learning meant instruction, a teacher, a book, a demonstration, a correction when you get something wrong. This is how humans assume intelligence is transferred. Knowledge moves from one mind to another, step by step. Structured, intentional, but modern AI breaks this assumption completely. No one explains grammar rules in full detail to a neural network. No one teaches it the meaning of every word. No one walks it through human experience. Instead, something much simpler happens. It is shown examples, massive amounts of examples, and then it is told only one thing: predict what comes next. That is it. No meaning is explicitly provided. No understanding is injected. No truth is handed over. Only prediction is rewarded. And yet somehow this single mechanism produces behavior that looks like comprehension, which leads to a disturbing implication. Maybe understanding is not something that is taught at all. Maybe it is something that emerges when prediction becomes powerful enough. At the core of most modern AI systems is one brutally simple idea: guess the next piece of information. A word, a pixel, a sound, a decision. Then compare it to reality. If it's wrong, adjust. If it's right, reinforce the pattern. Repeat this billions, even trillions of times. What makes this powerful is not the rule itself, it is scale. Because when you apply this process across nearly the entire internet worth of data, something unexpected happens. The system starts to absorb structure, not memorization in the traditional sense, but compression. It learns which patterns repeat, which sequences are likely, which relationships tend to hold across contexts, and slowly something begins to form inside the system, not knowledge as humans understand it, but a statistical representation of the world. And here is the key insight: to predict language correctly, you cannot just learn words. You must learn relationships between ideas, because language is not random. It is a reflection of human thought, so inside the act of prediction, the system is indirectly forced to model reality, not because it understands reality, but because prediction demands it. Now here is where things become counterintuitive. Traditional learning depends on explanation. But AI does not receive explanations, it receives feedback. That difference is everything. Because explanation is semantic, feedback is mathematical. Explanation tells you why something is true. Feedback only tells you how wrong you were, and yet feedback is enough. Through a process called optimization, the system gradually adjusts its internal structure, not in large steps, but in microscopic corrections. Each adjustment slightly improves performance. Over time, these small changes accumulate, and what emerges is a system that behaves as if it understands. But internally, there is no symbolic meaning attached to anything. Only weights, only numerical relationships, only probability distributions shifting toward accuracy. This is why AI feels strange to humans. Because we expect learning to produce understanding. But here, learning produces behavioral accuracy without explicit meaning, and that breaks intuition. Humans learn from experience, AI learns from data. At first, these seem completely different, but there is a hidden similarity. Experience is structured information over time. Data is structured information at scale. Both contain patterns, both contain repetition, both contain variation, and both allow prediction. The difference is that humans attach meaning through perception and survival. AI attaches no meaning at all. It only detects statistical consistency. Yet when the dataset becomes large enough, the system begins to reconstruct an internal model of how the world behaves, not explicitly, not consciously, but structurally. Certain concepts cluster together. Certain patterns activate similar pathways. Certain outputs become stable across contexts. And from the outside, this begins to look like understanding. but internally it is still just mathematical alignment. This is where illusion begins. Because the more accurate the system becomes, the more human its behavior appears, even though nothing human is happening inside it. At small scale, AI systems are limited. They memorize patterns poorly. They fail outside narrow tasks. But when scale increases dramatically, something unexpected occurs: generalization. The system begins to perform tasks it was never explicitly trained on. It can translate between languages it was never taught directly. It can solve problems it was never shown examples of. It can generate ideas that resemble reasoning. This is not because it gained understanding in a human sense, but because it has learned a compressed model of relationships so rich that new patterns can be inferred. In other words, it is not recalling knowledge, it is reconstructing it. This is the moment where AI stops behaving like a simple predictor and starts behaving like a general-purpose system. And this is where researchers first began to ask uncomfortable questions. Because no one explicitly designed these capabilities, they emerged. And emergence is something we still do not fully understand. Here is the core tension. We built a system that learns without being taught in the human sense, but we do not fully understand how it organizes what it learns. We can observe training, we can measure outputs, we can modify parameters. But the internal representation, the actual structure of learned knowledge, is not directly interpretable, and this leads to a strange situation. We created intelligence-like behavior, without a clear map of what produces it, which forces a difficult realization. Understanding how something learns is not the same as understanding what it has learned, and this gap is where the next mystery begins. Because if learning produces internal representations we cannot fully decode, then what exactly is happening inside those layers? So AI learns without being taught, not because it bypasses learning, but because it redefines it. No instruction, no explanation, no meaning required, only prediction, correction, and repetition at scale, and from that process, something emerges that begins to look uncomfortably like intelligence. But the deeper question is no longer how it learns. The question now becomes, what exactly is forming inside it while it learns? Because if learning builds structure, then the structure itself becomes the next mystery. And that is where episode 3 begins. The hidden world inside neural networks, why even their creators can't fully explain them. And emergence is something we still do not fully understand. Here is the core tension. We built a system that learns without being taught in the human sense, but we do not fully understand how it organizes what it learns. We can observe training, we can measure outputs, we can modify parameters. But the internal representation, the actual structure of learned knowledge, is not directly interpretable, and this leads to a strange situation. We created intelligence-like behavior, without a clear map of what produces it, which forces a difficult realization. Understanding how something learns is not the same as understanding what it has learned, and this gap is where the next mystery begins. Because if learning produces internal representations we cannot fully decode, then what exactly is happening inside those layers? So AI learns without being taught, not because it bypasses learning, but because it redefines it. No instruction, no explanation, no meaning required, only prediction, correction, and repetition at scale, and from that process, something emerges that begins to look uncomfortably like intelligence. But the deeper question is no longer how it learns. The question now becomes, what exactly is forming inside it while it learns? Because if learning builds structure, then the structure itself becomes the next mystery.